Hello, in this quick video, I'm going to show you two examples of multidimensional arrays and pointers in a C programming language. So let's begin quickly by going over the first question or the first example. We want to find out the outcome or output of the following program. So imagine you have this main function. We're going to begin with the first line. Char star message equals strdup. As an input parameter, we have this constant string. strdup is a function available in string.h, and it basically duplicates a given string and stores it in the heap. When you have a constant string like this, it is stored in the data section of your program. But by using this function, you can copy it into a empty space in the heap that is going to get stored safely and securely, and you can basically manipulate that copy whenever you want. So this is a pointer to the beginning of the copy of this string in the heap. Then what I'm gonna do here is we create some space for an array of strings. We call it a char double star array. The reason we have two stars is because this is gonna be an array of char stars. The first star basically means we are going to store char stars. The second one means we have an array of char stars. So it's like having an array of strings in Java. And we are going to allocate enough space for it by calling the malloc and 7 times str, 7 times size of char star. We are ensuring that we have enough space to store 7 char star or 7 pointers to characters, which is going to be 7 strings. And we are going to cast the return value of malloc to a char double star. Remember, malloc always returns a void star. So if you want to set it equal to a char star array, you must explicitly cast it. Then, as you see here, we are calling strtoke to tokenize the message over space. This function basically gets the first word of the message, which is going to be the word this. And it's going to store a pointer to it in the char star word. Char star word is going to be a placeholder for all the words of this message. As I go down in this code, you will see that we are basically tokenizing the original string, and we get different words of it, and we are going to copy those words into the heap. So let's go one by one. First, we get the first word. Then we set I to 0. Then we say at index I of the array that we created in the heap, let's store, or let's set that equal to some empty space allocated for us in the heap. The size of that array would be strlen of word plus 1. So imagine, because the first word is going to be this, this has 1, 2, 3, 4 characters. We are going to allocate 5 bytes. Why are we allocating 5 bytes? Because 4 of those bytes will store the 4 letters in the word this. The last one is going to be used as a extra \0 that we always use at the end of strings to end the string. After you allocate 5 characters or 5 bytes here, you're going to use strcpy to copy the word, which is going to be the first word of this message, this, into this location. This location, when I is 0, would be the beginning index or the beginning cell of the array array. As I told you, array is going to become an array of char stars. So this is a basically pointer to the first cell. This is going to be the first word of the array. we're gonna store the first word we're gonna store the first word of this sentence in the first word of this array. And then we are going to do I++. So in the next iteration, I is gonna become 1. And then we're gonna say, let's set word equal to strtalk null in a space. This null basically means I'm gonna use the previous message that I passed before. So that means I would like the strtalk to tokenize the second word of the same sentence. So after this we have is, so the next value or word is gonna be the word is. And then we're gonna do this again in the next iteration, because this while word, the while word is going to check the value of word, and because it's not null, we're gonna continue the do while loop. In the next iteration, we're gonna store in R1 because I is gonna be 1, some pointer to the free space that we are going to create for the next word, which was the word is. And then we are going to copy that word is into star R plus I. Let me tell you one quick thing about this. This is basically equivalent to RI. Let me explain why. When I add a pointer with a constant, that means I'm advancing that pointer. That's called pointer arithmetic. So when R points to an array of char stars, R plus I would basically point I cells forward in the array of char stars. And then when you apply an asterisk on it, asterisk is called a dereferencing unary operator. We are basically getting the ith index. And that's basically how we do it normally with the help of a bracket. I intentionally used this notation so you can see this and remember this, that this is going to be always equivalent to when you use bracket with a array name on the left side and an index inside that. So basically I'm storing word, which is the second word of that message, which is going to be the word is, into the array at index I. And then I'm going to do I++, and then I'm going to call the strtalk again with null and a space. That means I'm going to get the third word, which is A. And I do the same thing. This is going to continue 7 different iterations because I have 1, 2, 3, 4, 5, 6, and 7 different words. After the 7th word, because there is nothing else, this word is going to become null because strtalk reaches to the end of the message and it returns null. Therefore, we're going to get out of the while loop, and then we are going to get into this for loop. Let me draw the final status of the array ARR when you reach to the line 18, so you understand how we're doing that final step of the program. So I'm just going to draw an array R, which is going to be an array of 7 char stars. This is basically a char double star, and it's going to have 7 different rows or 7 different cells, whichever you want to call it. I have 0, 1, 2, 3, 4, 5, 6. Let's add one more here. So let's put these here. This is going to be the char star that we're going to store. These are basically of index 0, 1, 2, 3, 4, 5, 6, 7. And the way this looks like is basically every single pointer here is going to point to a different word. The first one would be this, which is T H I S, and then after that you're going to have a backslash 0. The second one is going to point to the word is, so it's going to be a 3-letter array, I, S, and then after that you have a backslash 0. So on and so forth. The last one, the very last one, is going to be message. So because the last word is message here, it's going to point to a longer array with M as the beginning, E as the second one, S, A, G, E, and then a 0 at the end. So that's gonna be basically the content of this array. Remember, these pointers are gonna be stored in the location that we allocated here. And each of these arrays like this, like is, like the last one, these are all also in the heap that we have allocated basically here using this malloc. This malloc basically allows us to allocate space for every single word that I just showed you. And at the end, because we are saying, let's print out, by the way, what is putchar? Putchar is going to print one character. So it's like a printf with a %c as a placeholder. So whenever you see a putchar, that means it gets one parameter and it puts one character in the output, in the standard output. So basically, what's going to happen here is we are going to go over all the 7 words that we have in the array, and we are going to print ri0. Ri means any of these cells. When I is 0, that means the first one. When I is 1 means the second one. When I is 2 means the third one. The second bracket, which is 0, means give me the initial letter. So this for loop basically prints the initial letter of all the 7 words in this initial message. So the output would be T, which is the initial of this, I, which is the initial of I, A, which is the initial of A, S, which is the initial of simple, S, which is the initial of 7, W, which is the initial of word, and M, which is the initial of message. And that's going to be the output. This is the end of the first example. Now let's get into the second example. The second example is also a very interesting example. This is about a multi-dimensional array. Multi-dimensional arrays are in every language. Like you can have a multi-dimensional language in Java, you can have it in C++, you can have it in C, C#, Python, you name it. You can have it anywhere you want. But the C version is pretty interesting because C allows pointers, and the pointers in multi-dimensional arrays would allow you to access different part of the arrays in different ways. You can use pointer arithmetic, you can use brackets, you can use asterisk as a referencing operator. You can do lots of things with it. So it's kind of versatile, but at the same time, it becomes really confusing. So I'll try to show you lots of details about the multidimensional arrays in this example. This example is fairly simple. You have an array of characters. We call it R, and that's basically is a 3-dimensional array. The first dimension has 2 elements, the second dimension has 3 elements, and the fourth dimension has 4. That basically means think of this as a 2-level story, 2-level building. You have 2 level, ground level or level 1, and then level 2. Basically, I consider these 12 characters as characters stored in level 0 or level 1. We're going to start with 0, so we don't say level 1. So these are basically the characters stored at level 0, and these are the characters stored at level 1. So in other words, let's make the following assumption. Let me move this down so I can explain that a little bit better. So my assumption is we are going to basically begin with R0. R0 would be, because the R itself is a 3-dimensional array, R0 would be a 2-dimensional array. This is a 3x4 rectangular array, right? Array of characters. And the next one, which is going to be here, these 12 characters that you see here are going to be the content of R1, which is going to be another 3x4 rectangular array of characters. Now you may say, why do we only have 2? The reason we have 2 is because of this constant 2. If it was more than 2, then we had more levels, right? So think of it like a 2-story building with 2 levels. Level 0 contains these values, level 1 contains these values. Each one of them would be a grid, would be a rectangular array with 3 rows and 4 columns. So for R0, I have 3 rows, row 0, row 1, row 2. So I will basically call this row an R00. I call this basically R01. And I call this one R02. Pretty obvious. Same for the next story. This story, because this part of the second story would be R of 1 and 0, because that's the first row in the second story, second level, I call it. Then this one is R of 1 and 1, and this is going to be R of 1 and 2. Each of these 6 rows would be an array of characters by themselves. So this one is an array of 4 characters. This one is an array of these 4 characters. This one is an array of these 4 characters, so on and so forth, all the way to the last one, which is an array of these 4 characters, right? So that's how things look like. If I want to read the characters next to each other, it's going to be how space, R space, U space, now space, and space, etc. And then you have a backslash 0. Let's get into the main function now. You're basically printing 3 strings and a character for the first printf, and then 3 string and another character for the second printf. So I'm going to show you each printf separately, and then we're going to make a sense out of each one. Between the strings, you have exclamation marks. So remember, we're going to use this exclamation mark to separate the strings and characters. Let's begin with the first one. If I want to print the array itself as an array of characters, which is %s, we basically have to read it from the very beginning all the way to the very end, which is going to be how space R space U space now space and space etc. You may be surprised why this is the case. If you are surprised of this output, it's because you don't know how a multidimensional array is stored in the memory. A memory in hardware is basically a very long one-dimensional array. So when we want to store a multi-dimensional array, we need to flatten it. Otherwise, you cannot store it. Like in computer hardware, we don't have multi-dimensional arrays. So a multi-dimensional array has to become a 1D array at the end. That process of converting a multi-dimensional array to a 1D array is called flattening the array. How do you flatten an array of, let's say, 3 dimensions like this? You need to first store the R0, which is the first level, and then you need to store the second level. When you're storing the first level, which is a 2D array, you need to start by storing the first row, and then the second row, and then the third row. That's called flattening a 2D array with row major, which means first store the first row, then the second row, then the third row. After that, then you're going to have the second story or the second level in the same way. You need to store these, then you need to store these, then you need to store these. Long story short, who is the neighbor of this character in the memory? This character. Who is the neighbor of this space? The left neighbor would be W, but the right neighbor would be A, because we're going to flatten it in row major. Who's the neighbor of this space? Left neighbor would be E, right neighbor would be Y. Who's the neighbor of this one? Left neighbor is U, right neighbor is N. When I say neighbor, I mean the cells that are sitting right before or after the cell in the memory. So when you flatten this, you're basically generating this whole string. That's why the printf with %s is going to print this whole sentence when you print R. When you print R1, that means forget about the first half, just print the second half. So the output will become now space and space etc. The reason is what I just told you, R1 is the second part. And by the way, I forgot to mention all of these curly braces are basically showing you the nested nature of this 3D array. Like on the outermost layer, you have R0 and R1. And then inside R0, you have like 3 rows. Each row would be inside, each row would be enclosed in curly braces, and each row will be separated from the next row using a comma. And all the stories that you know from your Java class maybe. So this is gonna be the R1. The next one is R11. So as I showed you before, R11 would be pointing to here. Right? However, because we are printing R11 with a %s, printf thinks of this as a string, so it doesn't end right here. It keeps going. Remember, I told you the neighbor of this is going to be D in the left side, in the right side, it's going to be E. So after a space, we're going to have E in the memory. So when the %s in the printf looks at this location, which is R11, it's going to read all the characters until it reaches to a 0. So basically, it considers the whole thing a single string. So what you're going to see is and the space etc. And finally, this %c, which is going to print R111, is going to print R1, which means the second level, R11, which means the second row, which is this row. And then the next one means go to the second letter of this row, which is going to be N. So we are going to print an N at the end. So that's the outcome of the first printf. What happens to the second printf? Let's discuss that one. The second printf is a little more complicated because it has less brackets and more asterisks, and the pointer arithmetic, always these are a little harder to analyze. So bear with me. Let's begin. When I say R+1, that basically is equivalent to what I had here, which means R+1 is basically a pointer to R1, right? So that basically means, let me use some kind of annotator. So that basically means we are pointing to here. When we point to here, we are basically printing all of that as one string, which is going to be what? Which is going to be now space and the space etc. Exclamation mark. The next string is going to be asterisk R+1. The R itself was a 3-dimensional array, so it's a char triple star. When you dereference it, you're basically referring to R0. Remember what R0 was? It was a 3x4 rectangular array. When you have a pointer to the a rectangular array of characters, which basically means, you know, this points to this whole rectangular array. When you add 1 to it, you're basically going 1 row forward. The +1 is just like saying, give me the address of asterisk R bracket 1. That means give me the address of row number 1. Why row number 1? Because it's a 2D array. So when you do the first bracket, you're just referring to different rows. So +1 basically means go 1 row forward and give me this location. So asterisk A +1 basically gives you the address of R01. So this basically means you're getting the address of R01. Where did I get the 1 from? This one is because you did +1. Where did I get the 0 from? Because you said asterisk R. You're basically referring to the first cell. Remember, the name of an array is pointing to the first cell. So when you say asterisk R, you're basically getting the first cell. You're getting R0. Always remember, name of an array points to the beginning of it. So when you say asterisk name of the array, you're basically saying R0. And that's basically give you the address of this letter A at the middle of the 3D array. And when you printed using person S, guess what's going to happen? I'm sorry, this person S. Guess what's going to happen? It's going to print all the characters from here all the way until you reach to the 0. Remember, you need to read it row by row. First, you read this row, and then you read this row, and then after that, you need to come to the next level and read this row all the way to the 0. So the output will be R space U space now space and space etc exclamation mark. Let me erase the annotations because we don't have a space. Now let's go forward. The next one is double asterisk R +1. Double asterisk R means first give me R0 and then the second asterisk applied on it, which means give me the index 0 of R0. So this basically means give me the R00. Grab the first cell and then the first cell of the first cell. So R0 was this rectangular array. When I apply another bracket 0, that would give me this array. This the array with how. When I add a 1 to this, that basically means I'm going to get the address of its second letter. Because this asterisk R is basically a char star. When you, like an array of characters, when you add 1 to it, it's like go one step forward. And that basically jumps over H and it starts everything from O. So guess what's going to happen? When you pass the address of O as a parameter of printf, and you wanted to print it like a %s, the %s is going to print every character starting from O. So it's going to be how without O, without H, space R, space U, space now, space, and space etc. It prints all of them. Because I started from O, so it goes all the way down to 0. Remember, %s is very brutal. It goes all the way to a 0. It doesn't care what's the next character. Is it part of the string or not? Just keeps going until it reaches to a \0, which is going to happen at the very end right here. So it keeps going all the way to the end. All right. The last thing is this. Let me make a sense out of this one. This one is a character, and I'll show you why. You see all of these asterisks, we're going to make a sense out of it. First of all, let's begin with the innermost structure, which is asterisk R +1. Asterisk R basically means R0, right? When you do +1, that means in this 2D array, which is R0, which was this 2D array, go to the second row, which is this row, and give me R01. Oh, sorry. Is that? So that's going to be R01. But because of this asterisk, instead of giving us the address, because of this asterisk, we are getting the actual R01. When you do +1, you get an address of this, but this asterisk here will cancel out this ampersand. So we're going to get add of 0 and 1 here. Then we're going to have a +1 again and another asterisk. A +1 again means give me the second element or second character in R01. So in this row, give me the second character, which is R, right? So this whole thing would be the character R, which is the R011. And then when you do +1, when you do a character, when you have a character like this, which is ASCII code of letter R and added by 1, you basically go one step forward in the alphabet. After R, we have S in the alphabet. Therefore, what you're going to see at the very end is S, which is going to be the letter in the alphabet after R. So this is the answer for the second printf, followed by a new line. You're going to have a new line here, and in the first printf, we had a new line. So that's it for this short meeting. Thank you.